Hello, prep2. Today we will study together a new lesson in Unit 2, lesson number 2, and we will study the wave nature of light. We know from before that light is a form of energy, and when it reflected from objects and falling on your eyes, it causes vision. Okay, so the light is an external factor that affects the eye, causing vision. In this lesson, we will study the nature of light waves, splitting of white light, energy of light waves, light behavior through different media, light travels in a straight line, and light brightness or light intensity. Okay, let's study the first point, nature of light waves. We know from the previous lesson that light waves are electromagnetic transverse waves. What's meant by electromagnetic wave? Electromagnetic wave, this means that this type of waves propagate through vacuum, don't need any medium, okay? And they are transverse waves because the medium particles vibrate perpendicular to the direction of the wave propagation. And in this graph, we form crests and troughs. Okay. The second point, we will speak about the velocity or the speed of light. And we know from before that the light waves through vacuum has a very high speed, which equal to 3 by 10 power 8 meter per second. And the speed of light, this means that the distance which covered by light in 1 second. Okay, and we know from the previous lesson that the speed equal distance over time, and we measure the distance by meter and we measure the time with second. Okay, there is one problem on this rule. Let's try to solve it. If he asks to calculate the distance between the earth and the moon, if you know that the reflected sunlight on the moon surface reaches earth after 1.3 seconds. Okay, now we will obey the rule which says that the speed of light equal distance over time. Okay, and now he need us to calculate the distance, so the rule will be distance equal speed by time. Okay, so the speed of light, we know that the speed of light equal 3 by 10 power 8, and the distance we don't know it, but we know that the time is 1.3 seconds. So we will write the rule which says distance between earth and moon equal speed of light by time, and after the calculations you will find that the distance we will put the unit of the distance meter or kilometer. Okay, let's speak about the visible light. We know that the electromagnetic spectrum consists of gamma ray, X-ray, UV, IR, and radio wave. Between the UV and IR ray, we will find the visible light spectrum. Okay, and the visible light spectrum it's one of the components of the electromagnetic spectrum wavelengths, and its range between 380 to 700 nanometer. كمان مرة, the wavelength of the visible light equal 380 nanometer till 700 nanometer. Okay, and this visible light contain or consists of the rainbow colors, okay, which start with red and end with violet, and we will speak about this point with details. The second point, we will speak in this lesson about the analysis or the splitting of white light. All of us know that the sun is the main source of light energy. Okay, so what's meant by the analysis of white light? Analysis of white light is a splitting of the white light into 7 colors, which we call them the spectrum colors. And the spectrum colors, they are red, orange, yellow, green, blue, indigo, violet. And we can get them by splitting the white light using glass prism. Okay, you should know that the spectrum colors have constant speed. They have constant speed, but they differ in the wavelengths, the frequency, and the angle of deviation. Again, they have constant speed, but differ in wavelengths, frequency, and angle of deviation. Okay, if we try to study the picture, we can see that the white light split into 7 color spectrum, starting with red and end with violet. Okay, if you know that the lowest deviation is light which is closest to the prism apex. Okay, so the red color has lowest deviation, has lowest frequency, and longest wavelengths. Again, the red color has lowest deviation, lowest frequency, and the longest wavelengths. Okay, in the opposite, you will see that the violet color has the highest deviation, highest frequency, and shortest wavelengths. Okay, and the red color is the nearest or closest to the prism apex, but the violet color is closest to the prism base. Okay, so we can consider that as we go from the red color into the violet color, passing through orange, yellow, green, blue, and indigo, you can see that the deviation increases, the frequency increases, but the wavelengths will decrease. Let's move to the third point. We will study the energy of the light waves. There was a German scientist who known as Max Planck. He discovered the energy of the light waves. Okay, and he considered that the energy of light waves is composed of energy quanta, and he called them photons. Okay, and he said that the energy of the photons is directly proportional to the frequency of the light wave. This means that as the frequency increases, the energy of the light waves will increase. Okay, and we can consider the rule as photon energy equal Planck's constant by photon frequency. The energy of photons equal Planck's constant by the photon of frequency. So if we try to compare between the photon of the red light and the photon of violet light, okay, we can say that the frequency of the red light is less than the frequency of the violet one. So the energy of the photons of the red light is smaller than the energy of the photon of the violet light. And this is why this is due to that the energy of the photon is directly proportional to the frequency. We have finished this part, and this was the first part of the lesson, and we will complete the second part in another video. Thank you and goodbye.